Today we will see that what is the Laplace transform and what it does to the function which is in a time domain. So basically the Laplace transform converts a function of which is in a time domain into the S domain in a complex domain, and in the complex domain the analysis is much easier which we can do in a time domain, but it is tougher in the time domain, and it is basically we can easily get this the the complex domain function because the differential equation is easy to solve by the Laplace transform. Okay, so here the function which we are going to which we are going to apply a Laplace transform may be stable or it may be unstable. So you know what is stable and unstable means. As a t approaches to infinity, the function value which is in a time domain it approaches to 0. It means that function is stable, right? But if the time approaches to infinity, the function value approaches to infinity here, it means that function is unstable. So I'm not going deeper into the how to do a Laplace transform and then that derivation. It is you can read in a book. I'm here to tell you some important things. Okay, some the intuition about what is the meaning of zeros, poles, why the value of s is negative in a control system, and why is the qs is much higher order than a ps, and what is its visualization, what is intuition, right? So f of s can be written like this. What does it mean? That it means that here the s is a variable, right, and t is also variable and t is integrating from 0 to infinity. So area of this which is in the curve, right, f of t e to the power minus st over the time domain, it comes out as a function of s, and we put here in this form. Any function can be written in the form of p of s by q of s, right? And see here, if we put s tends to infinity, what it become? It will become 0, and over the time domain we will get 0. Area is 0. So it means that f of s is 0, right? Because the area tends to 0 as s tends to infinity. See, something you got.